Hello, everyone. On behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. My name is Janine Donnelly. I'm the manager of webinars for IBM Systems Magazine, and I will be the moderator for today's event. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources. You'll find that on the left side of your screen, and you can download the slides right from the platform without being disconnected from the webinar, so be sure to check that out. Today's webinar, Integrating Java Batch into Your Existing z/OS Batch Environment, is sponsored by Software Engineering of America. Our featured speakers today are David Follis and Sal Del Conte. Dave has been a member of IBM's WebSphere Application Server Development Team for 20 years. He's the runtime architect for WAS on z/OS and the lead architect for IBM WebSphere Java Batch. Dave has authored numerous white papers and is a frequent presenter at conferences. Sal is the Vice President of Services and Support for SEA. He's a 40-year IT industry veteran with experience in batch optimization and development lifecycle best practices. Sal has authored articles and white papers, and he too is a frequent speaker at industry conferences. So, with our introductions complete, Dave, I'll turn the presentation over to you.
Okay, thanks. So let's just get started. So I'm going to open up by just talking a little bit about batch and why you maybe want to do that in Java and how that led us to JSR 352, which is the open standard for Java batch. Then we'll go into some of the details of JSR 352, take a look at some of the pieces in there and how it works, and then take a quick look at the IBM implementation of JSR 352 inside WebSphere Liberty and some of the operational extensions that we've added. Then I'll hand it off to Sal, and he's going to talk about some considerations for implementing Java Batch and what SEA has done in that space. So let's get going here. Batch processing obviously has been around for a really long time, going back to the beginning of computing, and it's something we're always probably going to have. Whether it's traditional COBOL batch run by JCL or something else, it's still batch processing, something running in the background, maybe at night, but more and more during the day. And it's just stuff that needs to get done to generate bills and do all sorts of other processing that just has to go on. So why do that in Java? And it's perfectly happy, in whatever language it's in now. Well, part of it is driven by people's desire to modernize their batch processing. Now that might mean just moving it into Java or some other more modern language than whatever it's in now. But it's also sometimes driven by just a need to change the application. You need to add in calls to a REST service or a web services thing, or maybe you want to refactor it and move some of the business logic out of the code and into a rules engine. Lots of different things drive the need to change and update batch processing. And so looking at writing it in Java is one thing people consider when they're doing that. Availability of skills is, of course, another issue. It may be that in your shop it's easier to find people or hire people with Java skills than it is with COBOL or whatever language your batch stuff is written in now. And, of course, on z/OS, it's a pricing thing. It's cheaper to run workload on the zip engines than it is to run on the GP, depending on how your pricing works for the software. So one question I always get when I first start talking about this is, well, yeah, but can Java run as fast as our COBOL or maybe even assembler that we've grooved over decades? Well, maybe. It's the usual IBM answer. It depends. The way Java works is that you write your Java code and compile it into Java bytecodes, and those bytecodes are interpreted by the JVM at runtime, which is not very fast. But a piece of the JVM called the JIT, or the just-in-time compiler, is watching what methods and which classes are being run, and it identifies things that are being used a lot. Well, in a batch application, you tend to be doing the same things over and over again repeatedly, so you're doing the same things a lot. And the JIT kicks in and compiles those bytecodes into object code for the platform where it's running. And so that obviously runs a lot faster. Furthermore, the more you run the same code over and over again, the more the JIT realizes this is a really important piece of code here. It gets run a lot. Let me see if I can optimize that just a little bit more. And so that's where the integration between the JIT guys and the Z hardware guys comes into play, because we've added a lot of instructions into the hardware over the years specifically to help the JIT optimize Java code so it runs really fast on Z. Now, you can get some of that with COBOL too, if you're recompiling your COBOL code, and changing the architecture level so that you're rebuilding with the current level of the hardware you have. The JIT does that automatically as soon as it sees new hardware is there. But for COBOL, that would mean recompiling your code. And usually when I ask people if they're doing that, about half of the customers will tell me that they can't even find the source code for their batch. There are instructions in some of the older hardware to take advantage of, that are there for the JIT to take advantage of, but of course we've added more and more instructions, so the newer the hardware you're on, the faster the Java runs. Let's see, so how do people get started with Java Batch? Usually what happens is they'll have some big long JCL job and they'll identify one step and say, we should write that one in Java. And so they'll change the steps, so instead of launching a COBOL program, it'll use the JSOS launcher to spin up a JVM and run some Java code. And usually that works really well. You pick something specifically to try this out on, it tends to work pretty well. The JVM starts, you run your Java code on the zips, it's great, you're successful. Well, success means you should do more, so it spreads and you start doing more and more of this. And so now what happens is your big 47-step job, you're starting and stopping 12 JVMs, and that seems a little silly. And also, application developers start building infrastructure. They start standardizing on how they want to do things, creating libraries to use, and they're sort of building their own framework. And you don't really want your app guys necessarily doing that, so that leads vendors to come out with their own frameworks. And so IBM has done that with WebSphere Compute Grid, Spring Batch is out there with some others, and that's all great, and so people start using those, but now you're locked into a vendor, and so we get pressure to create an open standard. And so that's what led us to JSR 352. If you're not familiar with JSRs, the numbers are meaningless. When you decide you want a standard, you just go to the standard body and say, hey, we want to create a new one, and they give you the next number. So 352 was just what was next at the time. It doesn't mean anything. So in order to create the standard, they first form a working group or an expert group. It's a bunch of people with some familiarity and history in this area. They get together, they have a lot of meetings, they argue a lot, there's a lot of phone calls, but eventually they produce a PDF that is the spec. And so that was finalized in May of 2013, and it's out there. You can go download the PDF and read through it if you're having trouble sleeping. There's actually 3 parts to the spec, though. The first part is the PDF, but there's also a reference implementation, which is a sample implementation of the spec. The source is made available, and IBM produced that as part of our involvement in creating the standard. It's just sort of there as a sample to prove it can be done. And then the third part of it is what's called the TCK. That's a test bucket that verifies compliance with the spec. So the reference implementation obviously passes the TCK, and any vendor that comes out with their own implementation of the JSR has to be able to run the TCK successfully in order to say that their implementation is in compliance with the spec. So that's really what it means. It doesn't mean that the vendor that wrote it read through the PDF really carefully. There's actually a test suite to verify they're in compliance. All right, so now we've got a standard, people can go implement it. So let's take a look at what's in there. So this is a diagram that I lifted out of the spec itself, and it shows kind of the main vocabulary around what's going on in a Java batch job in JSR 352. Right there in the middle, we have the job. That's good. And jobs are made up of steps, just to the right. And the little asterisk means the job can have 1 or more steps. That's good. Inside a step, we're gonna do stuff. And so sort of a traditional thing for a step to do is to read some data, process that data, and then maybe write something somewhere. It's reading records from a database table or a flat file. It's doing some sort of business logic. And then maybe it's inserting rows into another table or, producing a report or whatever. The interesting thing about the spec here is that it's broken those things up into separate pieces. So there's a reader, a processor, and a writer. And so that allows you to get some code reuse. So you could have a reader that reads from some table, and then you've got several different bits of business logic that process that table for different reasons. They can all share that same implementation of the reader because the reader's just reading the data. It doesn't really care what the processor's going to do with it. And of course, the processor, that's where the business logic goes. So it could be right there, or it could be a call out to a rules engine or whatever you need, but it's isolated in the item processor. Then over on the other side, we've got job operator. The spec defines the job operator interface as the way that you talk to the batch container in order to get it to do things and to find out what's going on. So there are methods on job operator to submit a job and to get a list of jobs, to find out what the current state of a particular job is. So that's how the spec leads you to interact with the batch environment. When we get to the IBM implementation later on, we'll see some things we've done to make that easier to use in a real enterprise environment. Then moving up to the top is an XML file containing what's called job specification language, or JSL. JSL is like JCL and ZOS. It's the definition of the job. There's syntax in there to indicate, here's my job. It's got these steps. This is what each step does, and so forth. We'll see an example of that in a couple of charts. And then down at the bottom is the job repository. For folks familiar with ZOS, this is really just the spool. This is where the batch environment keeps track of what's going on. The spec doesn't really talk too much about how the job repository is implemented, but it implies things it's going to need to be able to do in order for this to work. Because, for instance, the job operator gives you a way to ask, what happened to this job I ran last Thursday? So the job repository is where we're going to keep track of that. So we know, okay, this is the job you ran last Thursday, and here's what happened to it. So all that information gets kept someplace, and that's where it goes. So the steps that I've talked about on the previous chart, where we were doing the read, process, write thing, in the spec that's called a chunk step. And that's kind of what we typically think of batch job steps doing. But the spec defines another type called a batchlet. And a batchlet's much simpler. It's just a step that gets control and does something. Typically, people use this to copy a file or to call a sort utility or something else that's just, I need to go do this thing. And if you started out doing Java batch, as we were talking about earlier, where you've got a step in JCL that just spins up a JVM and runs a Java main, that Java main can probably become a batchlet pretty easily because it's a piece of code that does something, so you can kind of drop it in here. It's the same sort of thing. And of course, a job can consist of multiple steps, and they can be, mixes of batchlets and chunk steps, whatever you need. All right, so let's look at an example here at a kind of high level. We're going to consider a really simple two-step job. Our job's called simple bonus. And actually, I think it's longer than that. But anyway, the first step is our generate step. And what it's going to do is be a little batchlet that's going to generate a comma-separated value or CSV file. So it's just going to start and write us a file. The second step is going to be a chunk step called add bonus. And it's going to read the CSV file that was generated by the first step. It's going to do some processing with it. We'll pretend there's account numbers and balances in there, and it's going to take everybody's account and add $5 into it, and then it's going to insert a row into a DB2 table representing the account and its new balance. It's kind of a faked up example, but it illustrates a lot of interesting points. All right, so let's take a look at how you'd package this thing, and then we'll take a look at the JSL. So Java batch applications are packaged as WAR files or as EAR files, which is typically how you package a web application or an EJB application to deploy into a server. Inside our WAR file here, you can see the class files for our Java programs that implement our batchlet, our generate data batchlet. That's our first steps piece of code. And then we have the reader, the processor, and the writer that are the implementations of our reader, processor, and writer to read our CSV file, add our bonus in, and then use JDBC to write a row into some table. Now, we show just the class files in here, but of course the Java source files could be included here too if you wanted. And then down at the bottom of our WAR file, you can see simple bonus payout job.xml. That's the JSL file that describes the job. And it's packaged here in the WAR file with the class files and potentially with the Java files. So thinking of this in a more traditional sense, this would be like having sort of one data set that's got your COBOL source, your load modules, and your JCL all in one package that you can haul around. And so that's kind of neat because from a change management perspective, you've got one thing that's got all the bits together, and you can move that around as you go through development, test, and production phases, and it's all packaged together. On the other hand, traditionally, you don't keep those things together, and your change control might want you to keep the JSL somewhere else, wherever you're keeping the JCL. And one of the IBM extensions that we've added is the ability to pull the JSL out of the WAR file and keep it someplace else. And so we'll talk about that a little bit when we get to it. So here's a bit of sample JSL. Hopefully this is big enough on your screen you can see it. And up there at the top, below the standard XML thing, we see we've got a job entry or job element that starts our job. And the ID next to it, simple bonus payout job, is the name of the job. So this would be equivalent to the job name on your job card in JCL, except of course that it's more than 8 characters long and mixed case. So we're modernizing everything. So the next thing down we have is properties. These are properties that are going to be used throughout the job that we set the values just up at the top. These are kind of like set variables in JCL at the top. And just to take the first one, we can see that we're setting up a job property called numRecords, and it gets a value from this complicated syntax here with all these quotes and pound signs and things. What that says is that the numRecords job property is going to have a value of 1,000, that's over on the right, unless it's overridden with a job parameter called numRecords. So when you submit a job, you can also supply a set of name-value pairs that are job parameters. So if I submit this job and I don't say anything, numRecords will be 1,000, but I could say I want to submit this job and I want to pass in a parameter of numRecords and set it to 5, then instead it'll override it and we'll get 5. And of course the names are all the same here because it makes it easier to keep track, but you can do anything you want. So we have a bunch more properties, and then we get to our step. And our first step, the name of the step is generate. And right next to it, you can see it says next equals add bonus. That's flow control. So the way the flow control works with JSL is that the first step that it finds in the JSL file is always the first step it runs. After that, it goes until it runs out of direction of where to go. So if it hits a step that doesn't tell it where to go next, the job's done. So if we didn't have this next equals add bonus there, it would run this step and stop regardless what else is in the JSL file. So it's not going to just cascade down through the file. So this is a simple flow control. It just says, after this step, go to the add bonus step, regardless what happened here. JSL also supports a bunch of conditional logic where you can go to different steps depending on how this step finished. If it failed, then go to, failure handling step, and if it worked, go to, things are working great step, or whatever makes sense. So inside our step, we see it's a batchlet step, and then we have our com IBM blah, blah, blah. That's our batchlet. So this is essentially, exec pugum equals a load module with a step lib telling you where to find it. And we see that the numRecords property is getting passed into this guy. That'll get injected into the generate data batchlet at runtime, so he gets the right value depending on how all the substitutions happened. The next part of our job is the add bonus step, and so then we see that this has got a chunk step, and it has an item count thing that we'll talk about on the next chart, so remember that. And inside our chunk step, we've got our reader, our processor, and our writer, and each one of these points off to the Java class that's going to implement the reader, processor, and writer, and you can see they get properties injected into them that make sense. And we don't have any flow control here, so this is the end of it. As soon as the step runs, we're done. Let's see. How does this deal with program? Well, Java itself doesn't really append, but it will throw exceptions. And there is JSL that you can put in here to handle exceptions that you're expecting. If you get an exception you don't expect, a null pointer exception or something like that, then the job's just, well, the step will fail. You can have flow control based on step failing and go somewhere. You can also identify certain exceptions that you want to handle specially. Suppose your reader reads a record and says, oh, you know, this record's badly formed. It could throw a bad record format exception, and you can have logic in the JSL that tells it that I want to skip this record and just keep going, and so the reader will just get called again to go read the next record. Checkpoint restart. This is the item count thing I mentioned on the previous chart. You can specify either a number of records or a time, or you can have a programmatic thing that gets control and decides when to do checkpointing. And what that means is that we're going to do the read, process, write thing in a loop until we get to the checkpoint, either by count or time or whatever. When we hit it, we're going to commit the transaction that's wrapped around this processing. And so what that's going to do is commit any changes that the application has made in its writer, but it's also going to commit checkpoint data that the batch container is keeping. So we're keeping information from the reader and the writer about where they're at, and we commit that into the job repository when we commit that transaction. So when we hit this checkpoint, we're going to ask the reader, what record are you on? And he's going to say, well, I'm on record 10 million. And we'll squirrel that away in the repository and commit it at the same time we're committing changes that the application has made. So if something bad happens, the job dies, and you have to restart it. When you restart it, we rehydrate that checkpoint information, tell the reader, hey, 10 million was the last record you left off on, pick it up from there. Another thing that's in the JSR, or in JSR 352 is split flow processing. Traditional jobs kind of flow like the one on the left. You know, there may be some branches based on conditional things, but you know, there's a sequence that the job kind of falls through. JSL allows you to define a set of steps as a flow, and so here we've got step B and C as a flow and step D as its own flow, and then we wrap that with a split, and that tells the batch container it can run these two flows at the same time. So the main job will be going along, it'll run step A, and when that finishes, it'll spin off step B and then C on one thread and step D on another thread, and when both of those things are done, it'll come back together and run step E. So that allows this stuff to happen concurrently if the flow through your batch job allows that. You know, step D obviously can't be dependent on anything happening in B and C. So, but it may be, you know, that you can do this in order to make the job run a little faster. The other concurrency capability we have is called partitioning. Instead of running different steps at the same time, a partition lets you run multiple copies of the same step at the same time. And each partition gets its own properties passed to it so that it knows what to do. So in our example here, we're going to process 10,000 records, and we've told it to spin up 10 different threads, and each thread is going to process a different range of data. So the first thread will get past properties that say you're starting at record 1 and ending at 1,000. The second thread gets different properties that tell it where to start and stop and so forth. And you can control that in JSL. You can hard code the, you know, how many threads and what the ranges are, you know, whatever makes sense to them in properties. If it's fixed, or there's a programmatic way that, you know, you could do a select count against a database and get back, you know, how many rows you've got and make a decision on the fly about how many threads to have. And so all those fan out, they run concurrently, and then it comes back together when they're all finished. And each of those, if it's a chunk step, they're checkpointing individually. So if something bad happens partway through, then and the job gets restarted, each partition can pick up at its last checkpoint independent of the other ones. So the JSR, the programming model, everything we've talked about here, all gets pulled into Java EE7. And Java EE7 was supported by Liberty Profile in 8556, which was, I think, like 3 years ago, maybe more. So it's been around for a while. And we've added some of our own extensions on top of the programming model to help it integrate into a real enterprise environment. So we've given you the ability to get a job log out of each job that's running. So as The job produces messages about, what happened in this step, what the exit status was, and so forth, or any messages that are issued by the application itself. All that gets put into a separate file that you can look at as, the job log for this particular job instance. We wrapped a REST interface around job operator. That allows us to submit jobs and work with, jobs that are running or, finished earlier, and see what's going on with those through a REST interface. We built a command line client that drives the REST interface, and so you can incorporate the command line client into a script or something else, and you might then use that to integrate it into your existing enterprise scheduler. So whatever you use as an enterprise scheduler may run JCL. A step in that JCL would run a script. The script will run our command line interface that will submit a job, a batch job, into WebSphere Liberty. The job runs, the job log comes back, it's written into the output of the JCL job, and your existing enterprise scheduler doesn't know the difference. It ran a JCL job, it finished and produced output. We support a multi-JVM configuration where instead of talking to one server and running the job there, it acts as a dispatcher and puts the job on a queue, and then you can have a nest of other Liberty servers acting as executors that are picking those jobs up and running them based on properties that you're supplying. And those executor servers can be on ZOS, on other ZOS platforms. You can spread it across the Sysplex, or they could even be on distributed platforms because it's the same programming model. So the interface between these things will get the work to the right place. I mentioned earlier we'll support inline JSL, which means that you could embed the JSL in the JCL that you're using to submit the job, and it'll come across the REST interface. We publish events at interesting points in the life cycle of the job. So you have a messaging engine with a topic tree, and as jobs start and end, steps start and end, checkpoints are taken, we're publishing messages into that topic tree about the job so you can watch and monitor things you're interested in. The Liberty Admin Center has a batch tool that essentially acts like SDSF and gives you a view of what's going on. So you can see jobs that are running, pull job logs for jobs that are finished, restart a failed job, that sort of thing. And finally, we write SMF records. We write a 120-12 record at the end of the job, at the end of each step, and that has information about the job as well as how much CPU it used, zip and GP, so that you can see what's going on in there. If you're interested in more information about the JSR or about the IBM implementation in WebSphere Liberty, there's a bunch of links here. I'm told you can actually click on these in the presentation, so you could click on it now and open this in another tab so you don't lose it. The key thing to remember is the one kind of towards the top there in a bigger font, the TechDoc WP102544. That's where the longer version of this presentation, as well as links to all these other tech docs and a bunch of other stuff is. So for the IBM Java batch stuff, WP102544 is the thing to remember. And with that, I'll hand it off to Sal.
Well, thank you, Dave. Hello, everyone. And Dave's given us an awful lot to think about. JSL looks extremely interesting, and we know that a number of our customers out there using ZOS batches, they have been for many years, will certainly look at this and see some value and go for it. And we're just thrilled when IBM, and Dave in particular, and I met, and we said, hey, you know what? SEA, with our many years, over 30 years of experience in helping our customers achieve an optimized, efficient batch environment, and in particular, linchpin around JCL, validation, runtime simulation, standards enforcement, we're just a perfect match to partner with IBM and go through and see how we could help bring that same kind of value for automation tools, and particularly for development tools, helping the developers in the JSL world as we do in the JCL world. So everything that Dave just went through brings up a number of thoughts that we have to go through. One of the things that we do working with our customers is really consult an awful lot about how they want to implement a life cycle process for managing their JCL, for example, and those same types of considerations you have to go through for any JSL implementation that you want to do. And I think that's a key factor here. What I'm going to do is go through some discussion around the high-level governance aspects and the similarities between what you need to do if implementing a JSL approach, and as you've done with your JCL approach. And then towards the end, I'll show you some examples of the way we've invested in and are beginning the development of the tools to help find defects in JSL as we do in the JCL world. So first off, let's talk a little bit about what are the things that we need to think about for implementing a Java scripting language. And they are very similar but different, as you do, say, for JCL. You have, as they alluded to in the beginning there, goes back to the 1960s, right? JCL and batch and covering your really mission-critical applications in most large organizations. The first thought you're going to go through is, well, geez, do we go in and convert all of this old stuff? Do we convert part of it? Do we, just use things, use JSL for things that we're looking at going forward as new? And one of the things that we've done is reach out to some of our customers. And they basically, by and large, told us that they're looking at it primarily for newer applications, newer mainframe apps, and considering looking back, as Dave mentioned, at maybe some key batch processes where they might want to flip a step or two to JSL where it makes sense. Well, then, of course, you have to consider who's going to code your JSL. Is it, do you make use of your existing application developers who are, obviously mainframe knowledgeable and JCL and COBOL knowledgeable and all that, or do you have your Java team work on the JSL? And it's a consideration because on the one hand you have knowledgeable people around the nuances of mainframe development, and on the other hand you have folks who really know Java well, and so there's a balance there that you have to think through. More than likely will not be developing on the green screen, right? So it's going to be a GUI-based IDE possibly, and I'll show you some examples of what we've done. And that's really the area where and the type of tool set that your developers are going to be looking at to develop JSL and obviously go through the testing and the promotion process. You're going to want to consider the lifecycle management of JSL just like you do today for your JCL and your normal software development lifecycle process. So that whole process of going through your lifecycle from development to test to stage to production, how is that going to be handled when you are having JSL versus JCL? And Dave mentioned some of the differences, of course, where you can have the JSL as just part of a single package that comprises all the other components as well. It's extracted out and be able to validate it separately or validate it as part of the package. So things that need to be thought through and how you want to do that. And yes, there will be and should be coding standards. Now, Dave mentioned the standards around JSL and Java Batch and JSR that he went through and that come out in 2013. But what I'm speaking more along the lines of here are your own site standards that will no doubt you'll be implementing for your particular batch applications and in conjunction with the normal JSL standards, right? And then of course being able to incorporate all these new concepts and what you're doing to go forward with JSL into your current DevOps initiatives and DevOps on the mainframe in particular, with this concept of trying to accelerate to quality sooner so that you can release sooner, even on the mainframe, finding defects through automation and putting tools in the developer's hands so that they can find and correct defects sooner than in the past, and enable them to get to quality much sooner, and ultimately quality sooner in the production environment. With that discussion, I put up here an illustration of a generic life cycle, but again, one that we all have to consider, whether it's JSL or JCL. It's essentially the same concept and the same governance and release type processes that have to be considered. And the ability to have automation at the various points within the life cycle as you move from stage to stage is certainly part of the JSL requirements as well, so that you have, again, going back to a DevOps initiative and a mesh to your current DevOps approach, such that you have high quality when the JSL gets to production as well, and you're able to release to production more quickly. With a thought on DevOps and a thought towards how can we accomplish the goal of using JSL as well, and that is what we've done is in the many times we've worked with customers to consult with them, is kind of come up with this thought process here of what might I observe in an environment that was trying to achieve a higher level of DevOps and a DevOps approach that accomplishes quality more quickly. And certainly these are the major points. There's quite a few sub-points, of course, but in essence, the major points include that the organization has the highest priority and investments in enabling early defect elimination, right? So you're providing to the developers at the earliest point in the life cycle and the development process as you can, the tools that they need to identify and correct defects so that they can turn around their testing more quickly and get to production more quickly with fewer defects, right? That includes, by the way, as I mentioned here in this bullet list, also knowledge and documentation aspects. So it includes the ability for the automation to be able to, for example, generate test cases automatically, so that a developer who's working in a particular area of an application or on their own particular application has the understanding through automation of what other areas they might be impacting, other applications that their change might be impacting. Those are the kinds of tools and automation capabilities that are critical to ensuring quality sooner, right? And then finally, and certainly I can't overstate the value of metrics and the ability to understand what it is that you have done through the lifecycle process, what the defects that you've identified, the defects that you've prevented, and the trending processes that appear as you find defects earlier and get to quality sooner. That enables you as a development organization to provide to management the understanding and the confidence level that you're finding defects sooner and that release can be done sooner, right? Another way of looking at it is the colored curve here is showing you that the more defects that you find in the development process means that you have fewer defects getting to production. And then the contrast of that is the dark curve is showing that the more fewer defects that you find, or the more defects that you find early, the higher quality you have when you do get to production. And that is all dependent on these kinds of capabilities, enabling the developers to have the tools and the knowledge, the information that they require in order to accomplish the defect elimination earlier. The metrics among being able to see pretty graphs and communicate in a pictorial form, the most important thing is that you have to capture the metrics at the very fundamental level, right? Capture the data that enable you to report in various methods and different perspectives, slice and dice the data in many different ways. And I would say there are a number of tiers to understanding what the metrics tell you. First and foremost, of course, is, what defects am I finding? What are, how many defects are occurring, and how soon am I correcting them, and what defects eventually end up in production, right? That type of a very basic understanding. But beyond that, the metrics also tell you many things if you analyze it in different ways. One, for example, is which of my developers are using the tool? Is my tool adoption occurring at the rate that we need it to have everyone actually get to the goals that the organization has for quality? Are particular types of defects more prevalent disproportionately? For example, are there too many security type defects popping up? Maybe I need more education for this particular development team in that area. Things like that are very valuable to organizations in understanding what how to focus training, how to focus understanding of what the tools are able to do. Ultimately, of course, the trending and the understanding of which defects are occurring and how defects are being reduced is what management needs to see, so that they can have the confidence level to allow releases on the mainframe to occur more frequently. So in summary, for this high-level discussion, before I get into some examples of the tool, when you're considering implementing JSL, you're going to want to certainly consider your strategy of how to go about doing it. Is it, all new stuff only, or partial conversion, or what have you, right? So that's one thing. You're going to want to consider your life cycle automation and the pieces of knowledge that are required and the tools that are required to really allow your developers to accomplish the testing and the defect elimination as early in the process as possible. The metrics to be able to understand what it is that they are doing and the capabilities that the tools provide, and finally considering the deployment process. Right, it is JSL. It's Java. It's different than JCL, and there's the package differentiation. So there's certainly some newer methods and different methods for deployment that need to be considered potentially, and that has to be considered and determinations made. With all that being said, then what we have done at SEA is encapsulated into our JCL product, or JCL Plus product, features and functions that also provide for validation of JSL. Now, this first particular slide I'm showing you is an example of our integrated development environment, our plugin for JCL. So those of you who are familiar with JCL will recognize this particular panel's editing some JCL. I had already invoked the JCL Plus validation runtime simulation for this JCL and identified on this left panel then all those statements where it identified defects in the JCL messages, and then of course it locates the same spot in the JCL edit member, and then also down below a list of error messages that occurred. I bring you this to show you that and talk about how the value and the automation that we've applied to JCL over the years is the same approach, the same value, and the same capabilities that we are providing for JSL. So now this next slide shows you some of the capabilities that, as examples I'm bringing up today, of what we're doing with JSL. Now, of course, JSL up in the upper center of the screen here is listed in this area. You see the Java code, and I've already invoked the validator, the runtime simulation, and it's showing you that there is a defect identified here in the JSL. Below the script language itself, we're presenting a flowchart view of that particular script. Interestingly enough, and those of you who know JCL, it's really cool because this is JSL it's a different paradigm, that old paradigm, right? And Dave mentioned this. There's the ability to run 3 steps in parallel, which is what's happening here. But the defect that we've encountered or that we have identified potentially is a potential loop, so that this script could come down at initiate these 3 steps, initiate the final step, and then unfortunately, or go back up and begin at the beginning again. So that may not be what the developer really wants to have happen. So we've identified it as a potential loop situation. That's in a developer environment, one-off working on a particular script. This next slide, let me see if I went one slide too far. Yeah, I did. Sorry, back up one. This next slide, now we're talking about, as Dave mentioned, the concept of packages and packaging a number of artifacts within a particular file. And so you see here we have the XML files and the various artifacts contained in them. Within that, we extract one and validate it, runtime simulation, validate the artifact and come up with potential errors. And in this case, we have a situation where we have an undefined or transfer to nowhere to an undefined label, right? Undefined location. This particular script is again exploded down here into a flowchart form, which I'll expand here a bit. So this is the full flowchart form of what's above and showing you that the transfer potential error missing the location for transfer. The other really interesting aspect that we provide in this is the aspect of knowledge of the application itself as well. I talked about understanding that when a developer is making a change to a particular aspect of the application, that it's extremely helpful to know what that change may be impacting, what other areas of the existing application or what other applications may be impacted by this change. And that is part of what this particular piece of the functionality of our JSL capability provides, and that is being able to identify the other areas that are used or would be impacted by this particular change, the other references for this artifact. So these kinds of capabilities are what we are providing with a JSL validation runtime simulation, and as well, by the way, standards enforcement. So via rules that you would define for your organization, just like you would do in JCL, you have naming conventions, you have coding conventions that are specific to your organization. Similarly, we have the capability to validate and enforce those types of standards automatically, which is critically important, and identify, of course, the normal, the syntactical or runtime failures that are defects that might occur throughout the process of the execution of the script. So those are the key pieces, the key automation aspects. And one of the things that we would like to do at this point is to ask any of you whose organizations you may be thinking about looking at JSL or have already begun an initiative. We would love to talk with you and ensure that we are including in the tool and the features and functions of validating JSL what you need and what will be valuable to your organization going forward as you deploy a JSL in your environment. So happy to talk to any of you for that and look forward to it. With that, I'm going to turn it back to our moderator for questions.
Great, Sal. Okay, we do have a lot of questions. A couple of inquiries about the slide deck. So if you join late, I just want to direct your attention to event resources on the left side of your screen. There you'll find a drop-down menu that will allow you to download a PDF version of the slide deck. You can do that right now from the platform without being disconnected from the webinar. Okay, let's get to your questions. First question, do older machines like Z196s have the JIT code on their CPU chips?
Yeah, so I'll take that one. The JIT's actually part of the JVM, and it's producing object code appropriate to the hardware platform it's on. And so certainly the JIT's taking advantage of whatever hardware you've got. So the Z196 had quite a few instructions that were put there to help the JIT, and the newer hardware that you get, the more of that sort of thing there is. But yeah, certainly there's stuff on the 196s the JIT can take advantage of.
Great. I think this one's for you too, Dave. Can you have a mix of COBOL and Java in a single step with this process?
Well, yes and no. It gets complicated. You could have a Java batch program running inside of Liberty and make a JNI call to native code to call COBOL. That's pretty complicated, so most people don't do that. The other thing we see people do is more from the other side where they've got existing COBOL code and they want to run Java from their COBOL batch. You could drive the REST interface and submit a Java batch job directly, or there's another totally unrelated to batch thing that's in Liberty called WOLA, WebSphere Optimized Local Adapters that you can use to reach very quickly into WebSphere, run some code, and get back. And that might be more what you're after there.
Gotcha. I'm going to jump to this one now. How can I get started experimenting with Liberty Batch and JSR 352?
So the thing to do is to go to WP 102.554. It's in the charts, the link to it, chart 18. And if you go there, there's links off to a bunch of different things, a lot of information. There's a sort of English language version of the spec called Using JSR 352. There's also a link to a lab that will take you through step-by-step setting up an Eclipse environment with the WebSphere development tools to help you build your first little Hello World Java batch program that you can run in Liberty embedded inside of Eclipse. That's the easiest way to get started.
Great. Okay, next question. Can you schedule JSL similar to JCL with scheduling tools?
Right, so your enterprise scheduler can run whatever it runs now, whether it's JCL or script or something else, and inside that, then you'd run our command line interface that would reach over and submit the job. I see there's another question about TWS. That's an IBM enterprise scheduler. It's either IBM Work Scheduler or Tivoli Work Scheduler. It actually speaks our REST interface directly, so you can add into TWS workflow a piece that is a Java batch job. And as part of the definition, you tell it where Liberty is, so it'll reach directly into Liberty through the REST interface, submit the job, wait for it to finish, and pull the job log back out. So it talks directly, and you don't need a sort of proxy script JCL job in the middle.
Okay. seeing as we're probably going to have to pick and choose with our questions because we have a great turnout today and great questions here. I'm going to jump to this one, Dave, and it may be one for Sal. I'm not sure, but I like it. Okay, all of the examples are read, process, write, very simple processes. Can jobs run that have many inputs and many outputs and complex logic? A single chunk input controller is not appropriate for many complex batch processes.
Yeah, so the spec only defines a single reader, and so if you have to, for example, read from multiple sources, and yet you want to keep them, kind of separate from each other, there's nothing in the spec right now to help you with that, although there are some issues open against the spec trying to address some of that, and we've been looking at some of those issues. Right now, you end up creating for yourself what we call an aggregate reader that then calls the other individual readers and sort of collects up their responses. The tricky part is that you're probably injecting properties for each of those readers, and how does the aggregate reader know which ones go with which readers? And that's sort of the thing we're trying to address in the next rev of the spec that we've been talking about.
Okay, great. And maybe this one's for Sal, but I'll let you guys decide. How improved are the exception description facilities?
Not entirely sure what you mean by that.
Yeah, good question.
Okay, let's go to the next one then. We have a lot.
Mm-hmm.
Okay, you said, just checking my time here, you said the checkpoint/restart process would let you restart a failed job. Are there capabilities in the programming model to handle errors in the job without failing? And then a little aside here, what if you hit a bad record? Can you recover?
Right, so that's the skip record processing. You can define exceptions into the JSL. For example, that a particular exception is skippable, and if your item reader reads a record, doesn't like what it saw, maybe there's a letter in the account number or something that can throw a bad record exception. The JSL knows that that's a skippable exception because you told it, and so it'll just call the reader again without passing anything to the writer or to the processor because it didn't get a good record. You can also define a skip listener that will get control whenever things are skipped and it gets past the exception. And presumably, in the exception object is information about the bad record so that the skip listener could record the fact that, this record's got something funky with it and you need to try and go correct that. And there's similar things to for more complicated scenarios where you want to retry reading it. Maybe the data source is flaky, and sometimes you just try again. You can get a better read. And some other more complicated scenarios. It's a bit much to get into here.
Okay. Well, unfortunately, that's all we have time for today. So if you submitted a question and we did not get to it today, please know that someone will reach out to you via email with an answer to your question. I want to thank everyone for attending today's webinar. I especially want to thank Dave and Sal for sharing their expertise with us today. Later this week, watch for a follow-up email with a link to a recording of this webinar. Other than that, that concludes our webinar. So thanks again, and have a great day.